G'day, Mr. Bennett here. Today I just want to go through the investigation on quadratics. This is the point of no return. So scenario is that you've got a helicopter going out to a stricken yacht. Alright, so they need to make sure, obviously they've only got a certain amount of flying time with the amount of fuel that they can carry. So depending on what the winds are doing as to how far they can fly out. So now, when we start looking at this example, the sort of things that you will need to do is we need to show that we can model the situation using quadratics, and I'll show you how to do that in a second. But when you're looking at the reality of the situation, there are lots of things to consider. Obviously, if you're flying out into a head breeze, it's going to take you longer to get to a point, and then if it is a tail breeze on the way back, then it's not going to take you as long to get back. Reality is, the wind doesn't always, go in the same direction all the time. Sometimes it actually can change direction, or it might be swirly. So those sort of things that you might want to talk about when you start looking at modelling this, the limitations, the human, or not the human, but the reality of the situation. It's not always going to be as simple as the breeze is into your face and then behind you. Also you'll have side breezes as well. So if you're going to do that, you need to consider obviously the effect of the actual speed that you'll have in the direction where you want to go. Alright, so there's lots of things to consider there that you can talk about in terms of the reality of the real situation. So part A, what you're going to do is you're going to say the helicopter's cruising speed is going to be 300 kilometres an hour plus 10 times the roll of a dice. Okay, so you're going to roll a dice. So the idea of this is so you're not necessarily working with the same value that another person in the class is using. Alright, so we'll get maybe a 12-sided dice for you to roll. And that should give you a reasonable chance to get something. Now, here we've got enough fuel for lasting 4 hours. Okay, so that's what you know is your flight time. Consider firstly the situation on a calm day. Right, so on a calm day, if you were flying, let's say we'll do it for 300 kilometres per hour. If you were flying, then at 300 kilometres per hour, you could go 600 kilometres out and 600 kilometres back, and that would give you your 4 hours. So if it was a calm day, then that here would be my point. Right, so my point there, which I can mark on my graph, will be that point there. So if I'm thinking, I've got an equation which is going from 0, it goes through the point 300, it goes through the point 600, it's a straight line going through there. Right, and there's a point from here, obviously looking at the 300 and then the 600. So it's where those two lines cross over is what we're doing here. So the example in the purple might be, this one here is affected now. I'm effectively saying it's going out at 200 kilometres an hour, because that 1 hour it's taken 200 kilometres, 2 hours 400 kilometres. And then here we're saying it's going to come back with, for looking at that, it's going to come back with 400 kilometres, okay, an hour, because it takes 1 hour to travel 400 kilometres. This point here, this intersect point, is in fact the point of no return. Now, if I obviously change that to being, well, it goes out at 100 kilometres an hour, then I'd be plotting that point there, be plotting that point there. So my line on the way out will be going there. If it's effectively going out at 100 kilometres an hour, it might come back at 500 kilometres an hour. So therefore, there'll be a line coming up here, and you would be drawing a line there and coming back here. It's where those two lines cross over is what we're looking at. Now, the best way I think of doing this is to find the intersect points. If you could find those intersect points and put them into Excel, you can have your X and Y coordinates. Right? So I'm just going to show you what that might look like in terms of a graph. So here's my points, my X coordinate, my Y coordinate. If you go to insert a graph and using the scatter plot one, right, click on there, If you click on those points and you can add a trend line, and I'm doing this pretty quickly, we're going to do a polynomial and just bring it across so you can see it properly. Okay, and we're going to display our equation. I'm going to display our r squared value. Now, obviously, for this example here, I've made sure, it's a nice quadratic. All right. So what it will actually do, it will find the quadratic equation for you for those points, and that's a good thing to do to compare what you have come up with your manual way of doing the equation as well. All right. So that's the first thing. Now, in the investigation, what we want to do is we want to model that using some real values. All right. So, and you can talk about what the actual point of no return is. In part B, we want to do the same thing, but we actually want to start using symbols rather than using real values. All right. So we want to come up with a general equation. So if you knew what the wind speed was, you knew what the distance from the airport was, and you knew obviously the time, you could actually work out, a flight plan. So, you've got the conditions from the Weather Bureau, and if you can actually do it. So it's not much point flying out and going, well, I can't make it. You'd need to then maybe send another type of vehicle, like another type of aircraft to get out there, or a boat. All right. So the planning part of that is actually using this general formula. Key thing for you to try and do is to show that you understand quadratics and you can model that. So obviously we're using the part 3 part on that help sheet, which is modelling the equations. So if you've got a vertice point and another point, you should be able to find the equation. So you need to be able to do that manually, which is really important. So key thing that you need to look at is the overall analysis. So discussion limitations, make it real. Right? Talk about what would happen in the real thing and the limitations of what this modelling has done. So you could suggest some improvements, and you can go on a bit of a tangent, and I think you need to do that. Can you predict the outcomes if you knew the wind speed? Well, that's using the original, the generalised equation. Can you formulate a theory on how this may change with 2 or more wind changes in strength? So obviously you could actually extend this project to looking at, after an hour, the wind changed to this direction. How would that actually change things? And can you elaborate on reasons why planning, designing a flight path would be useful in the journey? So there is a little bit in here. It's not a super long investigation. It's really about using the modelling part of quadratics, and that's what you need to show. Right? When you start looking at the mathematics that we're requiring you to do, right? And I'm not going to read through these, but I think if you're looking at these dot points, they give you a guide to what I'm looking at. All right? So that's something that you can look at that will actually help you. So keeping it quite simple. The plan of this thing is to come up with your own graph. Now, I would be doing this thing on maybe Excel, right? And coming up with the model, as I showed you over here, comparing that with what you would do manually if you were given these points manually and you had to try and model it. That would be what I'd be doing. And obviously, if you need some help with the investigation, you need to catch up with one of us teachers. All right, so that way, it's about going out. Any investigation that we do is always about showing that you actually understand the mathematics. All right, so I can't give everything away. I want you to think about how you could extend this project so you're showing me and the moderator that you are in fact an A grade student.